This is chemistry, liquid, solids, intermolecular forces, and energy. So here we'll look at some examples using the heat equation. So the heat equation is Q is our heat flow, M is mass, delta T is our temperature change, and Cp is specific heat. So in the first example, it asks how much heat is needed to warm water from 25 to 95 degrees Celsius in order to make a cup of green tea. So we're trying to find Q. So the heat needed to warm, and here we have our delta T. So it was at 25 degrees Celsius, and it was raised to 95 degrees Celsius because it was heated up. The cup holds 250 grams of water, so that's our mass. And since this is water, you need the specific heat of water, which is 4.18 joule per gram degrees Celsius. So the first thing I'm going to do is just cancel out our units. Gram and gram cancels, Celsius and Celsius. The next thing I'm going to do is subtract my temperatures. So 25 minus 95 is negative 70.0. So this is not a negative value. What that means is that you had a temperature change. And if it's negative, that means that we felt heat coming from this system, right? Remember, if Q is negative, it's exothermic. So you were heating water to make a cup of green tea, which is a hot beverage. All right, now all you have to do is solve. So you multiply. Okay, so it equals 250 times negative 70 times 4.18. And you get negative 73,150 joules, and you need to check your significant figures. So we have 4 in my answer, but there's 3 here, 3 here, 3 here. So you need to round this to negative 73,200 joules. And that should make sense. So it's a deal of energy in a hot cup of green tea. All right, now this next example is directly referencing a lab that you will complete. So what I'm going to do is break this down by substance. There's actually 2 substances mentioned here because it's how you actually calculate what we're looking for in a particular lab. So it starts with a 50-gram sample of aluminum. So aluminum will be purple. I'm just going to fill in the parts of the heat equation that we have. So it's a 50-gram sample. Okay. Is removed from hot water that is boiling at 100 degrees Celsius. So what I'm going to have are samples of metals in boiling water, and you will come by and grab a sample from that boiling water and quickly add it to a calorimeter. Okay, so what you need to do here is realize that this is your initial temperature, right? So it was actually at 100 degrees Celsius, which is right here. That's where the aluminum was to start off with. And next, it's going to reference the calorimeter. So you quickly add it to a calorimeter. What's in that calorimeter is water. So let's see what we have for water. All right, 100 grams. Okay, was originally placed in the calorimeter at an initial temperature of 20 degrees Celsius. Okay, so 20 degrees Celsius. Okay. All right, after the aluminum was placed in the calorimeter, so you take the aluminum out of the hot water, you add it to a styrofoam cup that has roughly room temperature water, and you place the aluminum metal in, and what's going to happen is they will both reach a final temperature of 33 degrees Celsius. So I'm going to put that here, water, and then here, the aluminum. Okay. And now we're looking for the specific heat of the aluminum. So I know you could look that up, but the point of the lab is for you to figure that out. So this is what we're trying to find. Well, something is missing here in order for you to find that. You don't have the Q. Okay, so in order to figure out the Q, you have to look at what the aluminum was put in. So how was that energy transferred? Through what medium? Well, it was through water. So if you can calculate the heat of the water, you can use that to help calculate the specific heat of the metal. Now, in order to calculate the heat of the water, you need the specific heat, which is usually that 4.18 joule per gram degrees Celsius. So I should have given it up here, but even in the lab, I'll probably reference somewhere, but I think I just forgot this example. But nonetheless, you have it now. All right, so if you calculate this now, so 33 minus 20 is 13. All right, if you cancel, gram, Celsius, it's Celsius, you'll be left with heat. Okay, so it's 100 times 13 times 4.18. You get 5,434 joules. Now again, it's 3 significant figures. So around this. All right, so that is the heat energy, or was the heat transferred, from aluminum to the water, right? So that water was picking up the energy. So you can use that now to calculate the specific heat of the aluminum. So I'm going to put it right here. All right, now we need to calculate specific heat. I'm going to rewrite this. Let's go back to purple here. All right, so 33 minus 100 is negative 67 for our temperature change. I'm going to times that by 50, which is, and sometimes life just works out this way. I'm just talking about significant figures here. Oops, I didn't put my units. This is gram, degrees, Celsius, and then CP. Okay, so the answer is 3350, and I multiply these. You have 3 significant figures in each of these. There's 3 in the answer. Life was kind to us here. Okay, now what do you have to do? Now you're trying to solve for CP, so you're going to divide. This will cancel over here. Divide. And by the way, this was joule. Okay, raise this up a little. Now let's calculate. So CP now equals, actually, I'm going to put that in purple. Sorry, I'm going to get my colors. No, purple. There we go. All right, there we go. All right, now 5430 divided by 3350, and you get 1.62 joule gram degrees Celsius. Now, if you actually look up the specific heat of aluminum, it's a little bit smaller than that. I think it's 0.89 something, and that's fine. This is a lab, right? So at least 1.62 is in a decent range, right? So there's error that could happen here, but this would be how you would calculate the specific heat of a metal. You have to use the heat of the water in order to complete that calculation. Okay, so this is a good reference for your lab calculation as well. All right, 2 more examples. Let's go back to blue. All right, beaker of water is cooled from 80 degrees to 20 degrees Celsius, and this should actually be, this is to help sig figs. 0.0. All right. All right, 50,000 joules is released. How much water was cooled? If the specific heat of water is 4.8 joule per gram degrees Celsius. All right, let's look at what we have here. Okay, beaker of water cooled from 80 degrees to 20 degrees. That's going to be a positive number. It is cooled, right? So this is endothermic. 50,000 joules is released. I'm actually going to put a decimal there. Let's make the sig figs a little bit easier. There we go. All right, how much water was cooled? So that's our unknown, is the mass. If the specific heat of water is 4.18 joule gram degrees Celsius. All right, so this will stay. The m will stay. 80 minus 20 is 60. And 60 times 4.18, let's see what we get. All right, and what can cancel? Celsius and Celsius so far. So back to blue. Okay, so this is 250.8 joule per gram. You're trying to solve for m, so you will need to divide. Out. The joules will cancel, and we'll be left with gram, which is what we want. 5, 8. All right, so you get 199.36, oops, let's round that, 0.4 grams. And if you don't like the decimal, you could do 200.0 gram, but you do need 4 significant figures. And there's your mass. Okay. All right, I believe this is my last example. 2, 3, and 4, okay. All right, last example now. Okay, so again, it's the Q equation. Let's see what we have. 10 grams of water is heated from negative 75 degrees Celsius to 175 degrees Celsius. So 175 is our final temperature, and it started at negative 75. 60 joules of energy are released. What is the specific heat of the steam? Okay, so we'll leave this alone. All right, let's put this in now. 175 minus negative 75.0. Okay, so nothing's going to cancel because we actually want all 3 units for our specific heat. All right, so 250, and that should be. All right, oops, 250 times 10. Okay, so when you multiply these, you get 2,500, but you need 3 significant figures, so we'll do 2.50 times 10 to the 1, 2, 3. And that's gram degrees Celsius and CP. So CP is what you're looking for. So this is out. The joule. Sorry, I do not write very well. All right, 2.50. Yeah, that was a decimal. 10 to the third gram degrees, and there's all my units. All right, so let's solve. Okay, 16 divided by. All right. You only need 2 significant figures, so there they are. So 0.024 joule gram degrees Celsius. Why is this not 4.18? Because this is not liquid water, it is steam. Okay.